so a little bit of this was already covered, but I'm going to go over how to interpret the DOS basics. So at the end of yesterday's class, you probably ended up with something like this, and you're trying to figure out what it means, and hopefully this will help out with that. So DOS, as he already covered, was density of states, and it's the number of states per interval of energy at each energy level. And then I found a definition for valence and conduction band that could explain it better than I could. So the valence band is the highest range of electron energies in which electrons are normally present at absolute zero temperature, and the conduction band is the lowest range of vacant electronic states. So technically it's just valence bands are going to be occupied and conduction bands unoccupied. And then the band gap is just the gap between the two. So we got this picture down here that kind of shows, you get the valence band at the low energy and the conduction band at high energy, and the band gap in between. And then you've also, you can usually tell what kind of molecule you've got, like an insulator, conductor, semiconductor, by the size of the gap. So here is just a general diagram of a DOS, and it shows that valence band would be like this part here, conduction band would be here, and then in between is the band gap. And then I was supposed to do something on the spin-polarized models too, and I honestly don't know a whole lot about it. I tried to find some stuff, but I couldn't find much. But I guess you could kind of tell what kind of metal something is by doing a DOS spin. And if this stuff wasn't in Chinese, I'd maybe know a little bit better. But this is about all I got out of that. So that's about it.
Okay, let's thank Andrew.